satellite communication. So first of all, we will discuss about the definition of apogee. So here, whenever the satellite is in elliptical orbit, the farthest point, okay, the farthest point from the earth of that orbit is called as a apogee. Okay, so one see here, whenever the satellite is in elliptical whenever the satellite is in elliptical orbit, the farthest point from the earth of that orbit is called as a apogee. So one see here, so from this to this, so here the satellite is in elliptical orbit. The farthest point from the earth of that orbit is called as a apogee. So the point in an elliptical orbit, the satellite is farthest from the earth is called as a apogee. So the distance, so here we have a distance, the distance between the center of the earth. So the distance between the center of the earth to apogee is called as a apogee distance. Okay, so same like that. So whenever the satellite is in elliptical orbit, the farthest point from the earth of that orbit is called as a apogee. The distance between the center of the earth and apogee is called as a apogee distance. Next one is a perigee. Okay, so whenever the satellite is in elliptical orbit and the lowest point from the earth of that orbit is called as a perigee. So one see here, whenever the satellite is in elliptical orbit, the lowest point from the earth of that orbit is called as a perigee. See here, lowest point from the earth of that orbit is called as a perigee. So perigee distance is the distance from the center of the earth, and perigee is called as a perigee distance. The distance from the center of the earth and perigee is called as a perigee distance. Okay. Next one is a look angles. So here the look angles are the angles to which an earth station antenna must be pointed to communicate with the satellites. We have two types of look angles, elevation angle and azimuth angle. Okay, so elevation angle and azimuth angle. So first of all, elevation angle. So here to perform the performance of the satellite communication systems, the direction of maximum gain of an earth station must be pointed directly at the satellite. So to ensure that the earth station antenna is aligned, two angles must be determined. They are azimuth angle and elevation angle. So first one is azimuth and elevation angles, both are jointly referred to as the antenna look angles. With geosynchronous satellites, the look angles of earth station need to be adjusted only once, as the satellite will remain in a given position permanently. So first one is a elevation angle. So it is the vertical angle formed between the direction of travel of an electromagnetic wave radiated from the earth station antenna pointing directly towards a satellite and a horizontal plane, or it is an angle that appears between the line from the earth station antenna. Okay na? So it is an angle that appears between the line from the earth station antenna. So the angle of elevation of a satellite is that the angle that appears between the line from the earth station antenna to satellite and the line between the earth station antenna and earth origin. Okay. So this is a angle of elevation. So this is a earth station antenna. Here it is a earth. It is a satellite. So it is an angle that appears between the line from the see here, the line from the earth station antenna to the line between the appears between the line from the earth station antenna. Okay. So next one is a azimuth angle. So here the azimuth angle refers to the direction where the north is equals to 0 degrees. So whenever the north is 0 degrees, then we consider it as a azimuth angle. So azimuth angle is measured in clockwise with respect to the north. So whenever once the azimuth and elevation angle is known, the earth station antenna can be pointed in that direction only. So for a geosynchronous station, the antenna will be remain in same that position. So for any other satellites, the antenna must be moved as the satellite passes over the head. Only for geosynchronous satellite, the antenna will be remain in that position only, but coming to other type of satellites, that will be moved, that means passes over the head. Next, satellite frequency bands. So we have 7 frequency bands. L band 1 to 2 gigahertz, for S band 2 to 4 gigahertz, coming to C band 4 to 8 gigahertz, X band 8 to 12.5 gigahertz, KU band 12.5 to 18 gigahertz, for K band 18 to 26.5 gigahertz, KA band 26.5 to 46 gigahertz. So we have we have 7 frequency bands. Coming to L band, 1 to 2 gigahertz frequency range is there. For S band 2 to 4 gigahertz, for C band 4 to 8 gigahertz, X band 8 to 12.5 gigahertz, KU band 12.5 to 18 gigahertz, K band 18 to 26.5 gigahertz, for KA band 26.5 to 46 gigahertz. Okay. So these are the frequency, satellite frequency bands. Coming to satellite link. Okay. So here this is a satellite link. Here it is a transmitting earth station. It is a receiving earth station. So whenever the signal is transmitted from transmitting earth station to satellite, then we call it as a uplink signal. So in downlink signal is the signal is transferred from satellite to receiving earth station. We call it as a downlink frequency. So satellite uplink. So an uplink is the transmission of the signal from an earth station to satellite. Okay. So uplink is nothing but transmission of the signal from transmitting earth station to satellite in a orbit. So uplink, so KU band 1.4 gigahertz, for C band 6 gigahertz. Next, downlink. So downlink is a transmission of the signal from the satellite to receiving earth station. Okay. For KU band it is a 12 gigahertz, for C band 4 gigahertz. This is a satellite. This is receiving earth station. So this is the overall satellite link. So transmitting station to communication satellite repeater, then again retransmission of the signal, that is a downlink signal, that is 4 GHz signal will be received by using this receiving antenna. First of all, we send the signal, that is a uplink signal, that is signal transmitted from transmitting station to satellite. So mainly the satellite link function is first of all an earth station transmitter transmits the information to the satellite. Again the satellite contains the receiver which picks the transmitted signal and that amplifies the signal and again retransmit that particular signal to transmits to the new frequency called as uplink frequency. So the signal being transmitted from the earth station to satellite is called as a uplink signal. So retransmit the signal from the satellite to receiving earth station is called as a downlink signal. Okay. So for C-band, uplink frequency is 5.925 GHz to 6.425 GHz. Downlink frequency is 3.7 GHz to 4.2 GHz. Coming to Ku band, uplink frequency is 14.0 GHz to 14.5 GHz. Downlink frequency is 10.7 GHz to 12.2 GHz. So typical antenna sizes for C-band 1.8 meters to 3.7 meters. Ku band 1 meter to 1.2 meters. So in this we have learned the different definitions of apogee, perigee, azimuth and elevation angles, uplink and downlink frequencies related to satellite. So quiz questions once you check. Okay, so see here all these. A geosynchronous satellite completes orbit in 24 hours. Apogee and perigee are the considerations when the satellite is in elliptical orbit. So uplink frequency for C-band is 6 GHz. These are the frequently asked questions. Define uplink and downlink frequencies related to satellite. Define apogee and perigee. Write short notes on azimuth and elevation angle. Okay, thank you.